Now let's look at the same chart, but with just a little bit different terms. We said we're lowering the temperature. The correct term would be to say we're de-superheating. That would be the correct term. So we started off at 220 degrees. We de-superheat down to what? Saturation temperature. And saturation temperature for 1 pound of pure water at sea level would be 212 degrees. 212 degrees. From there, since we turn the flame off and we're not heating it anymore, we're losing heat, we're giving off heat. The water is giving off heat to the ambient air. What we can say is that now we're removing latent heat of condensation. You're condensing it. You're turning it from 100% vapor, because it was superheated, down to 100% liquid. So all along, this path is going to be saturated, a mixture of the two. The percentages, they don't matter. If you have 1 drop of liquid mixed in with a vapor, that makes it saturated. If 99% of it is liquid and only 1% of it is vapor, then it's still considered saturated. Once it has reached that point where it is 100% liquid, then we can lower the temperature. Since we're lowering the temperature, we can say that we are subcooling. That would be the correct term. We are subcooling. The actual definition of subcooling is lowering the temperature below the saturation temperature. Lowering the temperature below the saturation temperature. De-superheating, we said it was lowering the temperature to saturation temperature. Subcooling, lowering the temperature below saturation temperature. So in this example, we're lowering the temperature down to 100 degrees. So let me ask you, we subcooled this water how much? We started off at 212, we ended at 100. So how much subcooling did we do? We did 112 degrees of subcooling. 112 degrees. That's how you figure out subcooling.